This is CPM Calculus, Chapter 3, number 136. So here we're asked to write a Riemann sum to estimate the area of function f between x is 2 and 3. And this is f of x, 9x minus 2, with 20 left endpoint rectangles. Okay? Then we're going to compute the actual area geometrically and calculate the percent error. Alright, so let's go ahead and look at the Riemann sum. So the Riemann sum, remember, let's just sketch this quickly. Here's a graph, right? F of x is just a line with the y-intercept of -2 and the rise over the run, the slope is 9. So it's going to be going up really something like this. Well, let's just make it go like this. You know, it's going to be really steep. It's going to be steeper than that. Okay. So this is x and y. But let's just say this is 1, 2, 3. Okay. So we're between 2 and 3. So we're all the way. Well, I'm going to keep drawing this. We're going to have 20. The area between 2 and 3. Whoa. So here's 2 and 3. If I can draw this line up here, right? So we want to find the area in between these 2 points, all this shaded region. Okay? So how do we do that? Well, the area of f between 2 and 3 is approximately, using Riemann sums. Remember, whatever letter I'm going to choose I. Let's choose I is equal to, we want 20 of them. So I'm going to go from 0 to 19, right? Because 0 to 19 is 20. Rectangles, remember the area of a rectangle is base times height, right? The base, what is the base going to be? Well, it's just going to be the width of every one of these rectangles that we draw up, right? And that's going to be the distance 2 to 3 divided by 20. So it's going to be 3 minus 2. 1 unit divided by 20 is just 1 over 20. So this is the base. Okay, the base is equal to 1 over 20. Okay, so it's 1 over 20 times the height. Well, the height is just going to be the function, right, starting at 2, and then, so the function at 2 is going to be the height of our first rectangle, because it's the left point, and then every time we're going to add 1 over 20 to get to the next rectangle, the start of the next one, and then the start of the next one. We're going to add 1 over 20 times I, right? Because we're going to do that for every rectangle. Okay? So let's go ahead and plug that into our function. Right? So this is still approximately from I is equal to 0 to 19, 1 over 20. So f of 2 plus 1 over 20i, and this is f of x, becomes 9 times 2 plus 1 over 20i minus 2. Okay, I'm just plugging it into f of x, this input. Alright? So how do we put this in our calculator? Well, we can put it in our calculator. I'm going to write it right here. Basically, you use the sum function, write the expression here. So that's going to be 1 over 20 times 9 times 2 plus 1 over 20i minus 2, close the parentheses, comma, the variable we're using I, right? Comma, the start or the low, 0, the stop, right, or the high, 19. So let's plug this into our calculator. Okay? So turn on your calculator. How do we get the sum? We'll go to catalog and scroll up until you get to the sum. Here we go. I just passed it. Sum. It even says in their expression variable low high. So the expression is 1 over 20 times parentheses, right? 9 times open parentheses 2 plus 1 over 20 times I. I is above 9, so I'm going to use alpha 9 to get I, right? close parentheses, minus 2, close parentheses. Okay? So that is going to be our expression. Comma now, I, so again, alpha 9, comma, 0, comma, 19, close parentheses, okay, enter. So this is what it's equal, right? So this is the approximate area is 811 divided by 40, or approximately even, the green diamond, enter, or approximately 20.275 units squared. Okay, this is also units squared. Alright, because we're looking at approximate area. Alright? So that's using Riemann sums to approximate the area. We use 20 left endpoint rectangles. So don't forget, we want to continue the problem. We're not done. Compute the actual area. So we want the actual exact area. So it's not approximated. So we can calculate that because what is this shape? This shape is right here, right? Whoa. And it's just a trapezoid, right? These sides, maybe I shouldn't have made it so. There we go. Let me use a different color. Here's the shape, right? It's a trapezoid. These sides are parallel. So remember the area of a trapezoid. So let's go ahead and say actual area. Just a trapezoid, so the area is going to be 1/2 base 1 and base 2. Well, what is the base 2? Well, let's plug in 2 to get this height. So 2 into this equation is 2 times 9 is 18, minus 2 is 16, so I know this height is 16. And this height here is 3 times 9 is 27, minus 2 is 25. Okay, so it's going to be 1/2 base 1 plus base 2 times height. So that's equal to 1/2 base 1 is 16 plus 25 times height. Remember, height is the distance between the two parallel sides. That's 1 unit. Okay, so let's go ahead and use our calculator. 16 plus 25. 41 times half is going to be 20.5. So the actual area is 20.5 units squared. Okay? So finally, we want to calculate the percent error. Okay? So what the percent error is, percent error, that is just going to be how much error you have. It's even in absolute value. It doesn't matter if it's positive or negative. It's just the amount of error out of the total correct. Okay? So the error is going to be subtracting these two, right? So it's going to be 20.275 minus 20.5. And the total correct, well, this is the actual area, so that's 20.5. All right? So put in our calculator, 20.275 minus 20.5 is negative 0.225. But again, it's the absolute value because we just want the error amount. So it's 0.225 divided by 20.5. And that's equal to 0.010976, right? And the percent then is going to be moving the decimal 2 to the right. So that's equal to 1.0976%. Okay? So this is the error where we're using 20 left endpoint rectangles. Right? So we don't get the exact area when we're approximating. We get approximately, and we're off by a margin of 1% approximately in error. Okay? So let's box our answers. This is, again, when we're approximating, this is the actual here, and this is the error this is the error percentage when we're approximating versus the actual area. All right. So there you have it. This is the end of CPM Calculus Chapter 3, number 136.